Hi, Math 2 Enhanced. So let's talk about the property of logarithms. Just like we had properties of exponents, logarithms, which is an exponent, also has those same properties. We've been calling the division property, you and I have been calling that the quotient property when we were doing our properties of exponents. So the product property, if you're multiplying this m times this n in a single log, you can write these as separate logs with the addition symbol. So the product property tells me if I am multiplying two arguments, that's the m and the n, that is the same as having them in separate logs that are being added together. So let's take a look at this log of 5x. This is a log of 5 times x. I am multiplying the 5 times x in a single log. If I want to expand this, expand means to write something bigger, to expand it. I can write this as two separate logs, the log of 5 and the log of x. And because it was 5 times x, I would need to add those two logs by the product property. What if I had two separate logs? I have the log of 4 plus the log of y. Sometimes I condense my logs. I write my logs as a single log. In this case, if I want to write it as a single log, since I have the log of 4 plus the log of y, that's the same thing as a single log of 4 times y using our product property. A single log's product is the same thing as separate logs being added together. Well, what about the quotient property? The quotient property would be division. And so in this case, you can see m is being divided by m. If you remember back to our variables, if you had x to the 6th over x squared, the same base, my quotient property would tell me I have a single x to a 6 minus 2. My quotient property became subtraction. The same thing happens here. My quotient, my division is m times n in a single log. But if I want to write it as separate logs, I need to subtract. Notice that m is my numerator, and it's the positive log that's out in front, and n is my denominator, and it is the log being subtracted after. So let's take a look at this log of x over 3. X divided by 3 is a quotient, it's division, and the x is my numerator, and the 3 is my denominator. So if I want to write this, if I want to expand this, meaning to write it as two logs, I would have the log of x, because it's on top, it's my numerator, it's positive, minus the log of 3, because it's my denominator, and this is my quotient property. If I'm doing division in a single log, then I'm subtracting multiple logs. What if I have multiple logs being subtracted? In this case, the 7 is going to be my numerator because it's the positive log, and x is going to be my denominator because it's the log being subtracted. So I'm going to write this as a single log, and 7 will be my numerator and x will be my denominator. The quotient, 7 over x in a single log, is equal to the difference of the two separate logs. What about my power property? Well, power property operates a lot like a windshield wiper on a car. It allows me to take my exponent and bring it down in front as a coefficient, or swipe it up and make it an exponent. In this case, the n is an exponent on the left side, and on the right side, this is a coefficient n. It's the same n, and I could have it in either place. So sometimes I'm trying to expand my log, and I'm going to take that 3 and I'm going to drop it down in front as a coefficient. So I'm going to write the 3 log base b of x. That's me expanding it. Sometimes I'm going to take my coefficient and move it up as the exponent. This is me condensing my log, and I'm going to have log base b of x to the 1/2, which we know is just the square root. So let's look at some examples of each one. Let's go back up and discuss the product property again. This column, I'm expanding my product property. You'll notice that this is x times y times z. So this is a single log and it's multiplication. If I want to write it as separate logs, I can do that, but it's going to have addition. So log of x plus log of y plus log of z. And I'm going to be adding each of those three single logs. Let's take a look at the third column. This is where you and I are condensing. So I'm going to use my product property the other direction. Notice that we're adding and we're adding. So instead I'm going to write it as a single log. I'm going to write only one logarithm, and I'm going to be multiplying the 2 times the x times the y. Because that's what I do when I'm adding separate logs. It's the same thing as multiplying each of those arguments of those logs. Division. When I expand division, remember this is my numerator and this is my denominator. So when I use my quotient property and write multiple logs, I'm going to expand this one. I'm going to have log of my numerator, it's positive because it was on top, minus log of my denominator, it's a minus log y because that was on the bottom. What if I had subtraction? Well, then my 2 is going to end up being my numerator, and my y is going to end up being my denominator. This becomes a single log, and my quotient is 2 over y. By the way, I often find students that write log of 2 over log of y. First of all, the problem is there's only one logarithm when you condense. And here I've written 2 logarithms. It's not the same thing. You only want to write the log one time. And then since we're subtracting these logs, I'm going to be dividing their arguments 2 and y. So let's take a look at this first problem. If I want to expand this, that means I'm going to drop the 2 down in front and make this even longer. So the 2 will be a coefficient, 2 log x. Now when I first look at this one, I don't really see my exponent. Let's rewrite the square root as x to the 1/2. Now I have an exponent I can drop in front with my power property, and this becomes 1/2 log of x when I expand it. What about when you want to condense something? That's when you're going to bring your coefficient back up as the exponent. So this would be log of y cubed and log of 5 to the x. So let's take a look at these guys on the bottom. So sometimes I have to do more than one at a time. So let's take a look at this. I think I can make this a little bigger for you. So on the left side, I'm going to condense these to one logarithm. So I want to write the word log one time. So let's look what's going on. I have an x plus a y. That's going to be my product rule. I'm going to be multiplying x times y minus a z. That's my quotient rule. So I'm going to be dividing by z. So my numerator is going to be my x times my y, and my denominator is going to be my z. So this was my product rule with my x plus my log x plus my log y, and this was my quotient rule when I was subtracting log z. So there's a couple ways to look at number 2. I'm going to take a moment and distribute this negative and just get rid of my parentheses. There's another way to go about it where you don't. But I'm going to distribute that for just 1 second. Log of x minus 3 log of y plus, I'm sorry, that'll be a minus 4 log of z. Let me just clean that up a little bit. There we go, minus, when I distribute that negative, minus 4 log of z. So first of all, unlike number 1, I have coefficients down in front. So when I condense, I use the power property to move those coefficients up as exponents because everything gets smaller, tighter, more condensed. So this is really log of x squared minus log of y cubed minus log of z to the 4th. So now I'd like you to notice that this is a minus and this is a minus. This is my quotient rule, and it's telling me that my y cubed, my z to the fourth, will be in the denominator, and my x squared is going to be my numerator. So I'm going to write log one time, and since my log of x squared was positive, my x squared goes on top. And since it's minus log of y cubed winds up on the bottom, and minus log of z to the z to the fourth also ends up on the bottom. What if I want to expand? That means I want to write multiple logarithms. So let's take a look at number one. This, first of all, is the product property between these two. So I'll be adding the log of x plus the log of y squared. Now, this is my quotient property. I will be subtracting then the log of z. So let's look at this. My numerator had my product rule. I have an x times y squared. So when I write them as separate logs, I'll be adding them. My denominator had a z. This is my quotient rule. So first of all, this was my product rule. That's why I added them. And this is my quotient rule. I'm dividing by z, so I'm going to subtract it. Now, I'm not really done with this answer. I do have one exponent that I can drop down in front with the power rule, because remember, I'm expanding. I want to write this as long as possible. I want to expand it as much as I can. That means I will drop any exponents down in front, and that would be my final answer. So number two, before I can get started, I need to think about this square root as an exponent. This is really xy to the 1/2. Because I'm expanding, I am going to treat the x and the y separately. So this is really log of 3, and now using my power rule for exponents, x to the 1/2, y to the 1/2. So now I have all multiplication here, so I'm going to add my separate logs. This becomes the log of 3 plus the log of x to the 1/2 plus the log, see if it'll fit, y to the 1/2. Now remember, I'm expanding, so all my exponents I want to drop down in front as a coefficient. So now I've got my log of 3 plus 1/2 log of x plus 1/2 log of y. I hope this was helpful, and I will see you in class. Thank you.